Okay, so it's recording. All right, so 13.7 plus 0.027 gives you 13.727. But when you add, you have to go with the lowest number of decimal places. So that leaves you 13.7. We all agree?
Yeah.
Okay,
Yes.
divided by 8.221. So 13.7 divided by 8.221 gives you 1.666. Wonderful number there. But the rule for multiplication division is you go with the lowest number of sig digs. So it's going to be 1.67 because you have 3 here and 4 here.
See, I was just confused because I thought you got 2 from the 0.027, so I put that as 2 sig digs.
You got to kind of have to do things in order.
Okay.
And because it's in parentheses, you got to do that one first.
Okay.
Next.
So for number 35 on the test, it was like find how many pure substances are there.
Okay,
and
what are they?
There's distilled water, oxygen gas, table salt, sodium chloride, hold up, drinking water, and hold up, I don't remember the other one. Grace, I sent it to you. Do you remember what it is?
I have it on my screen. Hold on, I can find it. It's distilled water, drinking water, table salt, sodium chloride, air, and oxygen gas.
Okay. Distilled water is as pure as we can make it. Okay. So in theory, distilled water is just H2O. Pure substances can be either elements or compounds. So yes, distilled water is a pure substance. Oxygen can be found on the periodic table. So oxygen is an element. So yes, it is a pure substance. Table salt. I love putting these things together in order to make you guys think. All right, as I keep telling you, table salt I can buy at Walmart for 59 cents a pound. Sodium chloride I can buy from Flynn Scientific for $59 a pound. What's the difference? Well, table salt, they're not too worried about the fact that it may not be completely pure. There might be some other white crystals in there that are not going to hurt us. It's not going to change the taste. It's still mostly sodium chloride, but they don't have to worry about purifying it completely. So this is going to be a mixture. While sodium chloride, whenever you see a chemical name like that, like sodium chloride, calcium oxide, that is a compound, so that's a pure substance. Same thing here between distilled water and drinking water. Distilled is as pure as we can make it. Drinking water, there's stuff in it. So that is a mixture. Air, is air an element? No. Is air a compound? No. Air is just oxygen and nitrogen and carbon dioxide. And particularly in the morning, there's also some methane because you people are real gassy in the morning. So it's just there. It's in the air. That's a mixture. Oxygen is one of the things that could be in the air, making it an element, which means it is a pure substance. You see how you're going to have to think it through?
Yeah, I didn't realize sodium chloride was a pure substance for some reason. I thought it was just a compound and not a...
Compounds and elements are pure substances.
Okay.
Okay. That means that you can break it down all the way to the smallest particle. It's still the same thing. Elements can be broken down and it'll be individual elements of the same type of atom. And then compounds, you can break it down physically break it down to the simplest molecule, which would be sodium chloride, H2O. Okay. Now, you could chemically break them apart into their individual elements, but that still does not mean that it's not a pure substance.
So what would table sugar be then?
Sugar, if you look up sugar on Wikipedia, you will see that it's C12H22O11, which means if they give you a formula, it is a compound, which means it's a pure substance. I can't give you a formula for air because the air is going to be different in Mars. It's going to be different on Earth. It's going to be different at different elevations. Mile High Stadium is not going to have as much concentrations of oxygen and nitrogen as it will at sea level. So there's no way to define air or table salt or drinking water with a chemical formula. I can see some of y'all's faces over here on the side of my screen. That's why I'm looking like I'm staring to the side. I could stare right at you, but that's looking at a camera, and that's kind of weird. See, I'm looking right at you now, aren't I? That's weird for me. All right, what else?
Hold on. Give me a second. On
I'm giving somebody a second. I have no idea who it is. It's a girl. Sounds like a girl. It's probably double G.
Yeah. So whenever we did the practice test, questions 54 through, what is it? 56, I think, were on the, what are they called? The energy diagrams.
Mm-hmm.
And I put C because it was like the, where is it? Hold on.
I drew it if you want to see that.
Yeah,
I want to see what you're talking about.
Like the activation energy, and I put the one that was like from, what is it? Oh, never mind. Never mind. I'm good. I made a dumb mistake. It's okay. It's fine.
Which one's exo? Which one's endo?
Well, here, wait. I can show you what I.
No. Which one's exo? Which one's endo?
Oh, endo is the one where it gains energy, and exo is the one where it loses energy. So the first one is endo, and the last one's exo.
Good.
That wasn't the it. It's just I put like the long. Had like A was higher up, and had like the curve. Then it went down.
The PA is going. So all I'm hearing is wah 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 wah.
Hold on. Let me see.
Let me finish this.
So on that part right there, I don't know if you can see it, but I put C because on the review part, it showed it down there, but then I realized that it actually starts up here, so it would be B. You know?
No.
Okay, well, I know what I missed, though.
Okay.
It's okay. We're fine.
Which letter is the reactants?
Hold on.
A, right?
Yeah, A.
Yep. Which letter is the product's energy?
B.
Which letter is the amount of energy lost or gained?
D.
D.
And which letter is the activation energy?
C.
Of these four letters, which one can catalysts affect?
C.
D or C? What did you say?
C.
Dog or
Cat.
cat?
Cat.
Yes, it is cat. That's right. So a catalyst lowers the activation energy. Next.
On the Kahoot, it had one on SIGDIGs, and I'm pretty sure it was 3 SIGDIGs, but it said that it was just a bunch of random letters and symbols. I don't know what the heck happened there.
Actually, I don't know what the heck happened there either. So let's see if we can't find it. Good way to study for the test as well is to do worksheet 5.2. Just don't do the chapter 5 questions because that's for the next test. It's just chapters 4, 3, 2. Actually, I think it's just 4, 3, 2.
Wait, so we didn't have to do like the front page of 5.2?
Oh, definitely. You have to do it for Thursday or Friday. The question is, but I was telling you that if you did the rest is a good test review, but not chapter 5, not the first part. The first part would be a good test review for the next test.
Okay.
All right, so how many are 3 sig digs? Is this the one you're talking about?
Yes.
Okay, so 0.020, if you were to plug that into the calculator, the 0 here, this last 0, can you see it? Can you see my mouse?
Yeah, I can, but is that question 3?
Yeah.
It was question 10.
That one doesn't have to do with sig digs. I'm not sure that they give it to you in the right order.
Oh, well, it was how many significant digits do these numbers have? And it was like 300 something, I think was one of them.
Well, here's the deal. That has to be it. Let's see the question. Okay, so here we have those numbers with weird zeros and stuff. You know by now that some of these zeros are not significant and some are. So let's let the calculator tell you. Remember, whatever the calculator tells you, think the reverse. So you plug in 0.020, here I am, 0.020, bam. You see what the calculator says? It says 0.02. So whatever the calculator tells you, don't believe it. So if the calculator says, hey, 0.0 is important, say, not important. So notice that the calculator dropped that last 0, it's because it is significant. So you have 2 right there. 200 right on the dot means there's 3. 303, if you have a 0 between numbers, it's not a placeholder, it's been counted, it's counted. And then 220 without a dot, and notice it includes it, that's because it's just a placeholder. It's not significant. Does that help?
Mm-hmm.
Let the calculator help you and just remember the calculator's lying to you. I'm getting older. I don't have as many hours ahead of me as you all do. So I'd like to use it wisely. I'm bored. By the way, October is Hispanic month, so I'm going to expect gifts from all of you.
What if I bake you cookies?
Almond flour. I can do almond flour and dark chocolate. Then I'll have real, and if they're still chewy, I'll have really good fond memories of you. Which might be to your advantage when I'm grading labs.
Okay.
Just saying.
So you can be bribed?
Officially, no. Okay. Unless you got something for me, we're going to call it over.
Ms. Moreno,
Yes.
I was wondering, are we allowed to use our calculator and our periodic table on the test Friday or Thursday?
Remember a couple weeks ago when I had you do a chemical symbols quiz and I told you, don't use your periodic table, that'd be cheating. That's the only time that you're not allowed to use your periodic table.
Okay.
Mr. Moreno?
Yep.
I have a question on the 5.2 worksheet. It's the distillation and the chromatography and the decantation, the evaporation one. I'm having trouble understanding like the differences.
Okay.
Between them.
I can help you with that. Separating alcohol from water. Those are two liquids. Decantation is when you carefully tilt a beaker over. You're assuming that you have two layers, maybe a liquid and a liquid or a liquid and a solid. And you carefully pour one out, not really caring if some of it goes away. All right. So if you want to completely separate alcohol from water, that's not going to be a good one. Distillation is when you enclose it all in a still. And in the video, I explained this. You enclose it all in a still and you use the fact that alcohol boils before water does. So as the temperature increases, when it gets to 78.4 degrees, you're going to start seeing it boil. And it will stay at 78.4 degrees until all the alcohol has boiled away. And you can collect it over on the other side. Once all the alcohol is boiled away, then the temperature will once again begin to increase. So it is foolproof. Once the first liquid begins to boil, the temperature stays stuck. And once you see the temperature moving again, you stop the whole thing because you have separated it. So that's distillation. That would be a really good one for separating two liquids. Separating salt over water with very little effort to you, okay? Chromatography has to do with colors. Chromo is color and graph means to write, writing with colors. So I would hold that for anything having to do with colors. Decantation, you know, is quick and dirty, and it's not very efficient. Evaporation now. Evaporation is when you've got a solid dissolved in water. Just let the water evaporate. It'll take a long time, but then you really don't have to worry about anything. That's it. That's the one. Completely separating sand from water. Sand are big old giant particles, okay? And water, teeny tiny. The best one here will be filtration. Why? Because just think of coffee filter. What's the job of the coffee filter? Prevent the coffee grounds from going in along with the water. You want the water to run through and the coffee filter to capture the coffee. Sand, the particles are big enough that a filter is going to hold on to them, letting the water rush on through the little pores in the filter. So filtration is really, really good for separating solids from water. Separating liquid from liquid would be distillation. Distillation. And then finally, pigment, color, chromatography.
All right. Thank you.
Is that you, Tucker?
Yeah.
You look completely different without a mask. Keep the mask on, son. Keep the mask on. That is so weird. I've been teaching so long. I'm making fun of it, but it is so weird. I've gotten used to you guys like this. I mean, the other day, I didn't even, the first time I saw Grace without her mask, I think, Grace, you were at flag practice.
Yeah.
You said, "Hi, Mr. Marino." I'm going, judging from the enthusiastic welcome to one of my students. Okay, start imagining this. And then I've noticed the hair and go, oh, Grace.
Well, you saw me whenever I got my picture taken for maskers too, and you screamed out in horror, so.
Yeah, that was just weird. So weird. You guys will come back to me, see me 10 years later, and I won't recognize you. Hopefully in 10 years, we won't be wearing masks, will we?
I don't think so.
Horrible things. Though I kind of like these things, the neck gaiter things, but they begin to smell after a while. I'm gonna have to wash this one. Well, can't wear it anymore. I'm getting bored again.
So on the test, there's not going to be anything about like ions and stuff, right? Okay.
Ooh, look, somebody's blinds. Oh, it's just Nick's. All right, 5-second countdown. 5.
For the, oh wait, no, never mind. That's chapter 5. Never mind.
Shoot, might as well. I'm bored.
Well, I was gonna ask for the test on Friday for the first page of the 5.2, the who done it. I was gonna ask if something like that was gonna be on there, but then I remembered that was gonna be chapter 5. So
In time, you will have a test on that. Five, 4, 3, 2, 1. Going once, twice. All right, my friends. Looks like we're done. I will see some of you tomorrow. The rest I will see. Navia, you look so strange without the masks. That is amazing. All right. I'll see some of you tomorrow. The rest
Was
I'll
that
see
a
you.
compliment?
Yes,
said
of
it looks
course
so
it's a compliment.
You said it looks strange without it, and then you said that's a
Some people you can extrapolate. You can extrapolate, you know, my mind kind of extrapolates out what the rest of you would look like. And you're just surprising. Sashi, I was able to extrapolate. Okay, but your face was surprising. No, you're a very beautiful young lady. Very beautiful. I like your lights. I like your lights. All right, gang. Nice spending some time with you. I hope I helped. Okay?
Okay.
Goodbye.